Hi everyone, welcome to another one of the videos where I'm going to demonstrate the VLSM variable length subnet mask addressing scheme using the physical view of the packet tracer. Once again, you can see the devices that are there, the topology. Some of the students have been asking me, sir, what is the main difference between the physical mode and the logical mode? To be frank, there is not much big difference. In our logical mode, if you remember, all the devices and all our menus are stacked towards the bottom side, isn't it? Here, you can actually get a visual description or visual uh, horizon of these devices. You can see directly where S1 is, S2 is, BR1, BR2. This is the rack, that this is the shelf that I have been talking about. Initially all your inventory is placed on the shelf, and when you want to create this topology, you bring these devices onto this particular rack and then connect the devices using the appropriate cables, isn't it? That's what you have been doing. And as I told you, there is not much big difference. The only thing is how you look at it, and I feel this is quite easier to use than what is given in the logical view. Okay, so let's get going. If you look at the question, what it is saying here is it is telling you that you have a couple of switches and couple of routers which you need to consider and which you need to create a topology of, isn't it? So let me drag the switch S1 first onto the rack, then followed by the BR1 router, followed by the BR2. You can see all these devices are marked over here. All the devices are clearly marked. The BR2 is here. Okay, so you just drag drop it. BR2 is to be drag dropped here, and then followed by S2. So I placed all the devices that are required for my topology, and now it's time to connect them according to the given requirements. Okay, so as I told you, just go with the copper straight through cable, and first we have to connect S1 with BR1. Now I take on the copper straight through cable. Let me zoom in a little bit. So on S1, let me select the appropriate or the right port number. We see there, you can see the FA0 by 5 here. Can zoom in a little bit, be much more clearer. Okay, this is the best you get. So FA05, and from there you have to connect it to the BR1's Z0 by 0 by 1 part. So if you just browse it here, you can see the port numbers. This is the console port, this is the auxiliary port, and this is the 0 by 0 by 1 port which you need to connect to. So I made the first connection. So S1 to BR1, from F0 by 5 to Z0 by 0 by 1. Now I have to connect BR1 to BR2 using these ports which is mentioned over here. So let me select another cable, and from BR1, so this is the second port which is Z0 by 0 by 0, gigabit Ethernet 0 by 0 by 0. Click on that, and now come to BR2. Once again, you have to select the right port. If you connect to a different port, it won't give you the required marks. So Z0 by 0 by 0, you just click on that, and I made this connection also. The second step of the connection is also done now. And coming to the last one, which is from BR2 to S2. So let me select another straight through cable, and from BR2, which is the Z0 by 0 by 1 part, to, let me select it. It hasn't been selected. Yes. Now let me come to S2, and S2 I have to connect to the same F0 by 5 port. So this is the F0 by 5 port. So I did make all the connections. I connected S1 to BR1, BR1 to BR2, and BR2 to S2. So according to the topology given, all the necessary connections have been made till now. So using the right cables and the right devices. So let us see what is written over here, and what you are actually expected to do in this VLSM. As usual, in your VLSM, you are asked to determine how many. You are given an IPv4 address, which is 192.168.33.128/25. Okay, and you have to perform a VLSM addressing scheme according to the requirements given in this particular topology. Now, if you look at the topology, if you can count how many networks that you need, 1, 2, 3, 4, 5, 6, you require a maximum of 6 subnets, and also for each subnet that the required amount of hosts is also given to us. So you have all the prerequisites for preparing this or for going forward with your VLSM addressing design. Now determine how many host addresses and subnets are available. How many host addresses are available in a /25 network? So let me just select this. How many host addresses are available? So I'll just write it down in a /25 network. If here /25 means a prefix of 25 gives you how many bits for a host portion? 7 bits. So 2 power 7 minus 2, which is nothing but 2 power 5 is 32, 2 power 6 is 60, 2 power 6 is 64, 126. Okay. Now, what is the total number of host addresses needed in the topology diagram? That's what he asked. So if you see, this is 40 hosts. So 40 plus 2 plus 25 plus 5 plus 4 plus 4, which is equal to 42, 67, 72, 76 plus 4, 80. So we have to prepare an addressing scheme which supports up to 80 hosts in the given scenario. So how many subnets are needed in the network topology? So the answer is for this is 80. And you're also asking how many subnets are needed in the network topology. If you think of it, as I told you, 1, 2, this is 1. Let me just change the color so it will be easy for us. So 1, 2, 3, 4, 5, 6. The answer for this is 6. Determine the largest subnet. Fine. So if you want to go for the largest subnet, the most number of hosts is required is number 40. So which gives you the BR1 LAN is the largest subnet. So BR1 LAN is the description for this largest subnet. How many IP addresses are required? As you just seen, we require 40 addresses. What subnet mask can support that many host addresses? If you think of it, to support 40 hosts, how many bits you need? If you take 5 bits, 2 power 5 gives me 32 minus 2 only 30. And if I take 6 bits, 2 power 6, which is 64 minus 2. So for this, the answer would be /26, because 2 power 6 is 64 minus 2 gives me 62, which is way more than the actual required amount of 40. So how many total host addresses can that subnet mask support? /26 can give you up to 62 hosts. No questions. And can you subnet the 162.168.33.128 network address to support this subnet or not? To answer this question, let us work this particular example by taking these requirements of 6 subnets and the individual host requirements of each subnet according to the same procedure that we followed in our earlier questions. Let me show you that. Give me a second. So this is our given network IPv4 address. Let us start working the same way that we used to do earlier. The subnet mask given is /25. So I have taken the last octet of our IPv4 address, in which the first bit is always fixed at 1 because it is already part of the network portion. So I am left with a total of 7 bits. Okay. So these 7 bits belong to the host portion and I can use them as required by according to the subnet requirements. So I have listed all my 6 subnets in the order, starting from the subnet which require the highest number of hosts to the last subnet which require the least number of hosts. Okay. So first things first, let me start with 40 hosts. In order to support a 40 number of hosts, the number of bits I require is 6 bits, which will make the subnet mask as /26, isn't it? It will make my thing as /26. As I told you, this particular thing is already fixed, so I'm not going to change it. So for /26, this also goes into the network portion. So I'm placing a 0 here. Okay. So for the first subnet, my subnet mask is /26, where I will be using these remaining bits. So if I place zeros for the network address, so anyhow, the initial 3 octets are not going to change. So I'm just going to write the last octet only here. So dot 128/26. And for the broadcast address, I just need to place ones here, 1, which will give me dot 191/26. So this is my first subnet address. Okay, this is the first subnet which is going to support 40 hosts for me. So this is done. The first subnet is done. I still require to design the scheme for 5 more subnets, isn't it? A total of 6. So let me change the color so that it will be easy for us to identify which subnet is which. Now let me write with this. Now, for the second subnet, I require only 25 hosts. For 25 hosts, to support 25 hosts, the minimum number of bits I need is number 5. So because 2 power 5 gives me 32 minus 2, one for the network address and one for the broadcast address, which will still leave me with 30 host addresses. So I prefer 5 bits. In case of 5 bits, then the subnet mask will be /27. So here, how do you find it out? Now /27 means my portion, my network portion will cover these first 3 bits, isn't it? So 24 for the first 3 octets, 25, 26, 27. As I told you, this is already fixed. So already I have 0, 1 here. So for my next portion, what I will do is I'll place 1, 0. This I am not going to change. You are not going to change because your subnet mask is /25. The 128 is constant. Now, place all zeros once again for your network address, which gives you dot 192/27, and place all ones here, which gives me dot 223/27. So this would be my second subnet, which is going to cover my 24. So this is my 40 hosts, and this will cover my 25 hosts. So this is the network address for the second subnet, and this is the broadcast address of the second subnet. So now let me take another value. The third subnet is 5 hosts. So in order to support 5 hosts, the least number of bits I require is 3, because 2 cube is 8 minus 2 gives me 6 hosts. So for 3 means the subnet mask will be how much? It will be /29, isn't it? So the last 3 bits will become part of your host portion, and all the remaining bits will be the part of your what? Network portion. So once again, the first 128 bit is came, it is constant. So 1, 0, I have already 1, 0, 1, 1 here. So the next step is, or the next combination I go for is 1, 1, 0, 0. So once again, for your network address, what do I get is, if I write like this, I get dot 224/29. And if I place all ones here, I get how much? Dot 231. So all this is 224, 228, 230, because this is the value 228, 230 plus 1 gives me 231/29. So this supports my how many hosts? 5 hosts. This is my third subnet. So let me draw a line again here. So this is my line, which gives me my third subnet. Okay. So now I got 1, 2, 3, isn't it? So this is the first subnet. This is the second subnet. This is the third subnet. So this is done. I'm just putting a tick mark here so that you will be able to easily understand all is design. So next I'm asking for how many? 4 subnets. So for 4 subnets, once again, how many bits do you require? I require a minimum of 3 bits. So once again, my subnet mask won't change and it will remain at 29. So I have to continue the same subnet mask. Once again, the 1 remains constant in 128-bit position or in the first position of your last octet. So we have 1100 already. So the next logical combination would be 1101. For network portion, you get all zeros. And how much you get? So 128, 192, 224 plus 8, which gives me how much? 232. So dot 232/29. And when you place all ones here, so 232, 236, 238, 239, dot 239/29. So this is your next subnet, isn't it? This is your next subnet, number 4. So this gives you 4 hosts. Done. Okay. So the next subnet which we are going to go for is, this is also done. And still I have to design 2 more subnets, isn't it? So once again, 1 remains constant. And if you look at it, I still require only 4 subnets. For that, once again, the /29 prefix would be sufficient because I require only 3 bits. 2 cube gives me 8. 8 minus 2 gives me 6 hosts. So I'm going to take this again. And I have placed it 1101. The next combination would be 1110. So I'm placing the 3 zeros over here. How much it is? 128, 192, 224, 240. So dot 240/29. And so I'm placing the same subnet mask 111. So 240, 244, 246 plus 1 gives me dot 247/29. So which should give me my 5th subnet, which once again supports 4 hosts. So this is also done. For the last subnet, so let me just count them. 4th subnet and 5th subnet. For the last subnet, I require only how many bits? I require only 2 host addresses. So for 2 host addresses, I need 2 bits. So my subnet mask will become /30, which makes it here, isn't it? So 1101. Okay. So the next one I will be is 1 here and 1, 1, 1, 1, and another 1 here. So which gets to me, okay, so 0, 0, which you will get is, count it, 192, 224, 240, 248, sorry, my mistake, this is 0, 248. So dot 248/30. After that, you just place 2 ones here, which will get me 250 and 251/30, which this is the addressing scheme, which we get one for 2 hosts, and this is my 6th subnet. So according to the given requirements, BR1 LAN, BR2 LAN, all the 6 subnets have been created. So let me fill the data in here. As I told you, the address, the first 3 octets, 192.168.33 remains the same. And I'm just writing the last octet. So it will be easier for us to write it in this manner. So for the first line, what is the network address? 128/26. What is the first host address? 129/26. What is the broadcast address? You have just written it down here. 191/26. For the second subnet, what is the network address? 192/27. And what is the first usable host address? The next one, 193/27. What is the network address? 223/27. For the third subnet, just write it down here, 224/29. The first one is 225 and the broadcast address is 231/29. Okay. And what about the fourth subnet? Come down here. 232/29. And the first usable host address is 233/29. And the broadcast address for that is 239/29. And the next subnet, the network address is 240/29, 241/29, and then comes the broadcast address, which is 247/29. For the last subnet with the two hosts, your network address is 248/30, and next comes 249/30, and the broadcast address here is /251. 251/30. So this is how you fill this table from this particular calculation of your VLSM. This is our given address, and you have broken this, or you have applied a VLSM scheme into 6 subnets, each with its own subnet mask and number of host requirements. From this table, you have to fill up this table. There are 2 routers, isn't it? The interface Z0/0, Z0/01. And the information how do you fill this is actually taken from the information provided in your PT activity instructions. Now, for this Z0/0, the IP address is, I'm just copying it from this table. This is actually allocated to this BR1 249, and because the subnet mask is /30, 255.255.255.252. I'm just writing the last octet, so it will be easy for us to understand. For BR1, here it is 129. If you are wondering how am I writing this, because I already completed this scenario earlier, I just read the questions and I will move back and forth for you to understand it clearly. So 129, and because this is /26, you get the subnet mask as 255.255.255.192. Okay. And for BR2, Z0/0/0, the address is given as 250, and here it is given as 252, the same subnet mask. And for Z0/0/1, 193, which is the second host, and here it is assigned as 224. Why 224? Because my subnet mask is /27 for the second host, or for the second subnet. So this, once you fill this, I'll show you how to activate and how to initialize these ones based on the instructions given in our packet tracer. Okay, just give me a minute. So getting back to our PT activity from where we left off, you can see that you can answer all these questions directly from the table that we just calculated from the given address. So what is the network address? What is the second largest subnet? We did calculate the VLSM addressing scheme, starting with the requirement of 40 hosts, then continued with 25 hosts. Next comes 5 hosts, 4, and 2. We calculated everything, and we have identified that this given addressing scheme is good enough to support all the 6 subnets with their desired host requirements. So I'm just leaving these for you guys, so you do not too much bother about it. These are all just generalized questions. And let me skip to the part 2, where you can see the actual VLSM addressing scheme. And this is just the table that we just filled up. We divided everything up. We have accepted the given IP address of 192.168.33.128/25, and we started working on the scheme where we divided that particular address into 6 subnets with the desired number of hosts per each subnet. Now, this is how. Assign the first host. You ask, you might, as I told you, you might have been wondering how did I write all those addresses there. So this is why. Assign the first host address in the subnet to the Ethernet interfaces. Let me write it down. Afterwards, I can still remove them later. So as I told you, it is asking that assign the first host address in the first subnet to the Ethernet interfaces. BR1 should be assigned to the first host address in the last link. If you remember, BR1 to BR2 link has got only 2 hosts. So the last subnet here, which is dot 248/30, and the first host address is /249/30, and the broadcast address is /251/30. This will be used here. So for Z0/0 of BR1, what I am doing is I am taking the first address, which is this .249, and because the /30 is there, the subnet mask is the same, 255.255.255.252. Similarly, we have to assign the Z0/0/1 also .129, and because this belongs to this particular BR1 LAN, which is of 40 hosts, you can see this LAN, the Z0/0/1 interface, which connects to the LAN of 40 hosts, which is this. This is here 128/26. I'm just writing them down for your reference sake. 192/29.232/29.240/29. Okay. So this is the first address I'm using in this particular subnet, which is .129, and automatically the subnet mask here is .192. That is 255.255.255.192. Similarly, for BR2, you can see that this G0/0 interface gets a second address, which is 2. There are only 2 addresses available here, .249 and .250. So automatically it gets .250. This address mask is .252. And for the other interface, it now connects to the next LAN, which is consisting of 25 hosts. So this LAN is connected to the G0/0/1 interface of BR2. For that purpose, I am assigning the first host address, which is .193. So .193, because it is /27, my subnet mask will be now changed to .224 or 255.255.255.224. So this is how you plan the VLSM. And now let me make the configuration here so that you can easily understand. Okay. So this is all we did it. And once again, let me just draw this up to a little bit. And okay, fine. Now let me get on with the configuration commands. Okay. So what it is asking is you just drag the main closet part and you do all the required ones over there. Fine, we already did them and we already made these connections. So establish a console and you make sure that all the C devices are powered on. Usually everybody forgets it. So you see, just switch these 2 devices and similarly go to your PCs if there is any and verify whether they are also switched on or not. You can see that this is already powered on. You can see this light green colored bulb over here. It is switched on. So this is switched off and this is switched on. So make sure before you start working on this any topology in physical mode, you have to ensure that all the devices are switched on first. Okay. Establish a console connection between a router and the PC on the table. So take a console cable, go to the RS-232 port here, click it, come to the router, because we have to you have to configure both the routers, both BR1 and BR2. So just go on to the console cable of BR1. I'm starting with BR1. So click on it, click on that. So a console connection has been established. So now once you click on this particular PC, go to the desktop, go to the terminal, click OK. Just click on top here so that you won't get disturbed by movement and press enter. Okay, press enter. No, I'm not going to do the initial configuration dialog. I'm going to go through my steps. And first thing first, enable configure terminal. I'm just using the shortcut. Now you have to assign the host name. Let us start from here onwards. Assign the correct device name. Because I'm now configuring BR1, I just type in host name BR1, enter, and assign class as the privileged class mode. So enable secret class, and it is asking me to put in E and F, it is asking me to put Cisco as the password for both console access and also remote access. For that purpose, what I need to do is line console 0, enter, password Cisco, enter, login, line VTY 0 to 15, enter, password Cisco, enter, login, enter. Okay. Now it is asking me encrypt the plain text passwords. Fine, I can do that. So service, let's use tab, save time. Service password encryption, so that all the plain text passwords are now encrypted. And then we follow it with the banner message, banner MOTD. Just remember that we are doing this only for BR1, and we have to do the same commands for BR2 also. Unauthorized access, not allowed. Okay, just you can type in any message that you want. And similarly, we have to do the same for BR2 also. But let me complete the address configuration of BR1, and then I will proceed on to BR2. So assign an IP address and subnet mask to each interface using the table that you completed in part 2. So earlier we finished this table, isn't it? So I hope everybody has written down when you're doing this problem. Just take a pen and a paper and write down the addresses so that we can start configuration. In BR1, I'm starting with interface Z 0 by 0 by 0, enter. We need to give the description. So for this is the description, BR2 connection and IPv4 address. What is the address that we assigned? But we just have written 192.168.33.1. This is BR1, right? 249, and your subnet mask is 255.255.255.252, because this link belongs to the last of the 6th subnet, which we assigned /30 subnet mask. A /30 subnet mask has to be given as 255.255.255.252, isn't it? So I have given that. Fine, enter. And what is this? Okay, fine. My mistake, IP address. And I can do this. Sorry, my mistake, IP address. That's all. Okay, that is done. And usually, what we have to do is you have to perform the no shutdown. So whenever you are configuring an address to a router interface, make sure you provide the description, give the right IPv4 address, assign any IPv6 address also, and any IPv6 link local address also, and then give the no shutdown command. Okay, so fine. So I did it on. So I completed for BR1. Okay, fine. Activate the interface is all done. So just let me copy all these commands. I'm just coming out. Copy running config to startup config. So I completed BR1. Let me close this off. As I told you, we can simply drag this, drop this to BR2 directly. That means I'm just removing the console cable from BR1 and reconnecting it to BR2. After reconnecting this cable, just click on PC1 again, go to terminal, click on OK, and now you should be able to see. Just press no for the initial configuration dialog. You should see the BR2 router. So enable configure terminal host name BR2, enter. Okay, and followed by the same configuration commands that we did earlier. Enable secret class line console 0 password Cisco login line VTY 0 to 15 password Cisco login. Okay, so after that, what did it ask? All then service password encryption banner MOTD don't enter without permission. As I told you, you can just type in anything you want in the banner message, which will be displayed if somebody tries to enter or if somebody tries to access your console port. Okay, that is all done. And now let's do the interface configuration. So interface, I think I missed one interface on BR1, right? I didn't do the G0 by 0 by 1. Anyhow, so I will do that. No problem. Z0 by 0 by 0. First, let me finish off BR2. Interface Z0 by 0 by 0. IP address 192.168.33.250 space 255.255.255.252. And don't forget the description part. Description, you can see this is the BR2 interface, which is nothing for the BR1 link. Okay, that is done. No shutdown. Similarly, interface Z 0 by 0 by 1, enter. IP address, what is the address that we are saying? So this is the one which I'm talking about. This is the table, the second link in this, the second point in the table, which is nothing but 192.168.33.193 space. Because this belongs to the second subnet, my subnet mask will be 255.255.255.224. Enter. Don't forget the description. Description BR2 LAN link. No shutdown. Okay. So I'm almost done. And let me copy the configurations. Copy running config to startup config. So I have to do the second one, which I forgot. So let me just remove this and go to BR1's console port. Okay. Click on the PC again. Click on the terminal. Click OK. And press enter. So on T interface Z 0 by 1. Enter description. Yes, BR1 LAN connection. You can give any description as long as you understand what you're giving. IP address 192.168.33.129 space. The subnet mask key is 255.255.255.192. Okay, enter. No shutdown, enter, and then exit, copy running config to startup config. Okay, so all done. And let me just see whether you have completed everything or not. Activate the interfaces, everything is right, but it's still showing that I did some mistake here. So let me just check the results to see what I did wrong. So on BR1, maybe I gave some IP address. Z0 by 0's IP address is wrong. It is showing that. So maybe I made a mistake. Let me just verify on BR1. Okay, so anyhow I'm connected to this. So BR1 IP address, I just typed in, see, I made a typing mistake here. Okay, so anyhow you guys can also know what to do when you make a mistake, isn't it? So BR1, and let me go into the IP, the same interface that we made a mistake, Z0 by 0 by 0, go up. You can see this, isn't it? See, I just made a mistake, an error where I have to type in 33, I typed in 22. For that reason, what I need to do is I need to first remove the IP address that I assigned. So no IP address. This will remove the IP address that we assigned to it. And so what I do is now freshly IP address 192.168.33.249 space 255.255.255.252. Okay, no shutdown. So this is a good example where you guys can also make mistakes. And as I said, I just made a typing mistake where I have clearly can check this. Now, this is one last point here where you are actually supposed to verify the connectivity also. Let me do that as well. Now we are in connected to the BR1's interface, isn't it? So the last step is test connectivity. So for testing connectivity, it is asking from BR1, ping the Z0 by 0 interface on BR2. So, okay, let me ping this, exit, exit. And what is the address of Z0 by 0 interface on BR2? It is ping 192.168.33.250. See, you got 80%, so the ping is working. Similarly, if you connect the same to BR2 and ping BR1, it will also get, you will also get 100% out of it. Okay, but the another thing to observe here is if you want to ping this address, the Z0 by 01 from BR2 or this Z0 by 01 address from BR1, it won't work because there has to be some kind of routing protocol set in place so that this BR1 can ping the addresses on the other side of the network. So this is how you work with VLSM and the physical view of the packet tracer. So I just tried to give you an overview on how to connect the devices, what to do. And as I told you, once you're done with it, you can just simply take this and put it back in like this. You can play with the physical mode as well a little bit. Now, okay, fine. So you can just work with these particular ones. Okay, so this is how you work with the physical mode. You can see all the types of different cables over here, and any other devices you need will be in the rack. As I told you, if you're comfortable enough working with one console cable and one PC, fine. Otherwise you can just drag top this PC down here, switch it on, take another console cable, connect this here. Okay, connect this here and connect to another switch or this particular one. You can do this too. You can have two console cables connected to the, say, to two different PCs. So either way, how you feel comfortable working with, you can work with it as long as you do it correctly. So thank you very much and good luck. So make sure that you do practice some of these physical mode activities before you take the final exam. So good luck, everyone.